Hello everyone, myself Jayaraman. I am from India. I'm working as a design verification engineer. So in this presentation, we are going to see how can we bypass the setup struggle or setup tax which we pay when we are trying to run UVM with Verilator. So the primary barrier is not a methodology; it's just the tool chain setup. So that's a pain point we are going to address in this presentation. So we are going to look at the framework which takes care of building and installing Verilator and UVM library, generating a makefile, test bench, everything. So it will take care. So for engineers, students, or hobbyists, so anyone can just run the script and it will takes care of everything. So after 30 minutes, we will have uh, uh, results for UVM test bench which ran with Verilator. So basically, this framework will take care of installing required dependencies. It will install and build latest version of Verilator. So and it leverages RT2 UVM framework. So it generates UVM compatible, sorry, Verilator compatible UVM test bed so that we can run with Verilator, and it will generate makefile test bench end to end. It will generate and it will run the simulation and it will uh, uh, finish it once the simulation is complete. So we can see the demo of the same. So basically how RT2 UVM works, right? So this for RT2 UVM we need RTL, this top file. So here in left side you can see. I hope you can see my. So in left side you can see the module end module. So it is a dummy DUT just for the demo. So this simple FIFO. So it has parameter input and output. So this what RTL to UVM does is, so we will pass this RTL file as a input. So rest everything is taken care by the RTL to UVM script. So here we are using PySlam, which that means linter, system log linter. So it will lint the RTL file and it will get information like input, output, parameter information. So everything it will get and it will store it in a variable. So and based on the command which we are passing mode, so it has two modes: EDA playground, Verilator. So here we focus on Verilator. So if you run with the Verilator mode, it will generate Verilator under Verilator underscore. So it will generate DUT name underscore Verilator folder. So inside that folder, it will generate interface, UM sequence item, sequence, sequencer, agent scoreboard, env, desktop, everything. It will automatically generate, and it will also generate a UVM driver and UVM monitor, but not the run phase. So if you run without LLM option, so it won't generate driver monitor run phase. So if you don't give LLM switch, it will just create a empty run phase. So the main goal of this to set up and bring up the test bench and make the simulation works. So currently we are not using LLM switch. So sometimes this output is not deterministic. Okay. So we are not going to pass LLM switch. So maybe you can give a try with this one. So it will generate, the point is it will generate the whole test bench and it will generate the makefile for Verilator. Okay, so it will generate a makefile which points Verilator compatible UVM library, and everything it will generate within this makefile. Okay, and the script will take care of running a simulation. So let's see a demo of this. So first time. So let's just clone our repo. So just change the execute permission. So this is how the script looks like. So first it will do the sudo apt update. Okay. So it will install all the dependencies which are required to run the relator and RT2 UVM framework. Okay. Step one, it will install all the dependencies. Second one, it will install the Verilator. It will just clone Verilator and it will run. It will build a Verilator like auto configure and it will install the Verilator. Okay, so if a Verilator is already installed, it will just do a hard reset and it will just check out the test master and do a git pull. Once the installation is done, it will just remove the permission executable paths. So next step 3 will be installing R2 UVM. So we just create a virtual environment. So in that we install pip and graphics, PySlam. So everything Google generative is to run with LLM mode. Okay, so it will install git clone everything. So it will enter into this RT2 directory and it will set the UVM related library path. So this is the main thing. So if we get an error while running the relator, while running the UVM simulation, we need to check this UVM home path. So once it is set up, it will just run a Python script. So this is where RTL to UVM comes in picture. So we will pass RT to UVM minus T is the test name. So we will pass sample duty.sv. So which is the same file which we see in the slide a few minutes back. And here in mode, I'm just giving a Verilator. So additionally, we can give minus LM for driver and monitor logic generation and minus C for coverage switches. So once this is done, it will just go to the generator test bench and it will just start the timer, see how long it will runs and it will start the simulation. So once the simulation is done, it will just print the time it took and it will print the Verilator version. So that's it. Okay, now I'll just run this script. So now the script will install one by one. So initially it will do a sudo apt update and it will install all the dependencies. Okay. So it will take I think around 30 minutes exactly to install the dependencies, build Verilator and run with UVM test bench. So for time being, I already ran here. So this is how the end result will look like. So we can see UVM warning info from coverage driver, monitor scoreboard, sequencer. So just a dummy DUT, and we will just randomize the input and we'll just send the transaction. So here you can see the Verilator 5.045 version, and it took around 30 minutes, 32 minutes to run the simulation. So yeah, this will be the output we will get expecting. So this I have tried in WSL in Windows. So it will be easy to run. So I have tried in Ubuntu also, which is in a virtual machine, but compared to WSL, running in a virtual machine, it takes more time, like twice this time. So this is the thing. So yeah, now it started to build Verilator. Okay, so it will take time, and this will be the end result. Okay. We'll just go back to slide. Uh, Before that, I can show you the output output of this generated response. The response will be already given later. So it will generate a make file. So this is generated make file. So it will so the RTL to UVM will take care of this UVM root path. It will pick up this test bench stop or DUT switches which are required to run dump switch if we need. And we can add a coverage option too. We can also enable VCD file. It will be generated based on the DUT input we are giving. So this will be the generated dispense. So it's generated dispense based on the input RTL. So let's see how sequence item. So this is generated sequence item. So based on input and output, it will select random rand bit extend function. So basic things it will just get in done. And it will generate a PNG file which will explain the how test bench is structured. So this is how the uh, output of the image will be look like. So whatever the DUT we will give, we will just take the DUT underscore top. Same it will print with hierarchy. So currently just support a single ENV single agent. So I'm planning in future I'm planning to upgrade with multiple ENVs. Okay. So that's the demo part. So in future, like as I said, I plan to upgrade the RTL to UVM framework for multiple ENVs. Just by parsing the RTL top file, the script should be able to create a multiple environment agents. Okay, that's the next version. And currently LLM integration basic stages. So I'm planning to upgrade the LLM integration with adding commands in document format so that we will generate a uh, uh, HTML file for it will be used for documentation and for code generation for run phase for driver monitor scoreboard logic. Okay. So this is all about have today. So I would encourage everyone to give a try and just let me know how it goes. So this will remove the it will remove the setup time. So it will just directly jump from 0 to UVM full UVM setup. So once everything is done, so once you know everything's working, you can start to work on your own projects. So and finally, thanks to Srini and team for the opportunities. Uh, Thanks. Goodbye.